All right, thank you everyone. We appreciate you joining us for this Process Map Education Series webinar. Today's webinar is going to be focused on using Six Sigma tools to analyze EHS performance metrics. My name is O'Neill Williams. I am the Manager of Strategic Accounts at Process Map. I will also be the moderator for today's session. And we have as guest speaker Dean Rossi, who is the President of Safety Culture Partners, LLC. A few housekeeping items before we begin our webinar. All attendee microphones have been muted to prevent any distractions. You are able to submit questions at any time during the webinar and are actually encouraged to do so using the questions tool or the chat functionality on your GoToWebinar console. We will have a Q&A session at the end of the webinar, along with several anonymous polls throughout. You are encouraged to participate in those as well. We will have a post-webinar survey to obtain your feedback on how we did on this webinar. And at the very end of the presentation, you will have contact information for both Process Map and for Dean Rossi. And now for a quick overview on Process Map. We are the premier EHS and sustainability management information system. Our customers utilize our world-class platform in 90+ countries around the globe, and we've been partnering with customers for over 14 years. Process Map's mission is to empower customers with information to help them preserve the environment, create a safe workplace, and ensure the well-being of their employees. In essence, we help remove the non-value-added administrative burden on EHS professionals. Process Map has an integrated cloud-based or SaaS platform that comes with a comprehensive suite of modules. Customer feedback is at the heart of everything we do. Our platform is Safe Harbor certified, supports 20+ languages and 100+ currencies, and allows for automatic units of measure conversions. We have very broad industry experience, working with companies in industries ranging from manufacturing to automotive to transportation. This slide shows a sample of some of our customers. For the objectives of today's webinar, we will be looking at understanding the importance of having an EHS MIS to capture vital EHS data, analyzing the data to see if your changes are achieving the desired results, looking at the importance of being graphical when reporting upwards in your organization, analyzing data to predict when you may be out of compliance, and learning 4 key Six Sigma quality tools to help analyze your EHS data. And now for a brief bio on Dean Rossi. Dean has over 25 years of experience, EHS experience, at the site, division, and corporate level. He has held multiple EHS positions at GE Plastics, has served as the past Global EHS Manager at Stanley Black & Decker, the past Global Director of EHS for a division at Ingersoll Rand, and most recently has served as the VP of Global EHS at Exide Technologies. Dean holds a BS in Industrial Hygiene from Purdue University and has an MBA with an organizational leadership and management emphasis. He is also a Six Sigma Black Belt. Dean, welcome.
Thank you, O'Neill. And I wanted to say good afternoon, in some places good morning, and in some places around the world, good evening to everybody who's with us today. We're going to talk about using Six Sigma tools. If you think about it, most of us are trying to get to world class with respect to EHS performance. We've shown this slide a couple of times that, when you start out in life, you get to a new location, things are usually in chaos, you're in reactive mode, You start to gather up your information, start to understand what's going on, and you start getting to be a little bit proactive. But in order to get to truly to world class, you really need to start preventing incidents from happening, and whether those be injuries or being out of compliance from an environmental standpoint, you got to be able to predict when those things are going to happen so you can get in front of it and be preventative. Once you get to the preventative state, you'll truly then transform your organization to be world class. So let's talk today about how we can get there. But first of all, before we start, I really wanted to understand the audience. We got quite a few people on today. We want to understand what's your familiarity with Six Sigma. Okay, so we're going to do a polling question here. Everybody's going to get a chance to vote. And what we really want to know is if you're not familiar at all with this subject matter, if you're familiar with Six Sigma, have you been green belt trained, have you been black belt trained, or have you been master black belt trained? So we're going to open up the polls here. So go ahead, and everybody, if you could, go ahead and vote or tell us where you're at with regard to Six Sigma. All right, we're going to wait a couple more seconds here, make sure everybody gets a chance to vote. And just a couple more seconds. If you didn't get a chance to vote yet or to tell us what your educational background is with Six Sigma, please do so. All right, we're going to go ahead and close the poll, and we're going to share the results with everybody so you can see where everybody's at. It looks like we've got about 11% of the people on the phone is not familiar with it at all. 33% of you said that you at least heard of it or know a little bit about Six Sigma. Nice to see that over half of you are green belts, and the 6% of the black belts, I'm a little nervous that you know, you're going to technically correct me as we go here, so be easy on me today as we go. All right, let's start off. Now, obviously, you know, learning Six Sigma is, you know, weeks on weeks of training. So obviously in this 1 hour webinar here today, we won't have the time to do the in-depth training, okay? But let's start off with some common manufacturing questions and statements. And I've certainly had these in my 25 years of working in the manufacturing world. You know, senior leadership, some of them nowadays, as we're going longer into our careers, a lot of them have been Six Sigma trained. So you may get a senior leader to ask you to see a control chart of your safety incidents over the years, okay? You may also, your VP of operations may ask you if spending the time doing VBS observations is worthwhile, okay? Here's one that always scares me, and it's actually happened to me in my career, is that the city wants to lower your wastewater effluent for BOD from a limit of 325 down to 275. And they ask you, is that okay? You know, your VP of operations may ask, you know, how capable are we to achieve compliance at the new level? And unfortunately, I've had the unfortunate experience of one day when I was working, the city itself that I was working in, and the state and city will remain anonymous, had a problem with the POTW, and that the EPA was after them for too many metals at their city POTW. So the city went out to all the manufacturing locations in the city to try to determine where the metals were coming from. So unbeknownst to us, they sat out in my sewer out in front of my factory for 41 straight days. And on the 41st day of them doing sampling, we blew through the filter press and released water out at the end of the filter press directly into the city, and we were out of compliance. So even though most permits in the United States say that you only have to take composite 24-hour samples once a month, there is precedence out there where the city can camp out at your outfall and do continuous sampling 24 hours a day for as many days as they want. So if somebody were to come to your location today and do that, how capable are you to be in compliance? These are real questions that face us on a day-to-day basis, and these are questions that we should be able to answer with data. right? So let's take a look. Today I'm going to teach you a little bit, or show you, I guess, on how to use statistical process control charts. The proper control chart for plotting safety incident rates is really what we call a U chart. And we'll talk about more about U charts here in a minute. For wastewater treatment plant data, the individuals, it's called an I and MR chart, it's called individuals and moving range chart is the proper chart to use for plotting your wastewater treatment plant data. We're going to also do some capability analysis on seeing how capable are you to maintain compliance. I'm going to show you how to do some simple regression analysis. When people come to us and say, hey, we changed X and we think that Y changed, or we know that Y changed, but yet they have no data to prove it. We're going to show you how to do that today. And then we're going to walk you through a student's t-test on how to test two populations with before and after you made some sort of change. All right? So let's take a look here. Oops. Hold on, I have a slight technical difficulty. All right, before your slide changed? Okay. We just did that one. Now, hold on, folks. We're just having a slight technical difficulty here. All right, hold it. We're showing that the slides aren't changing here, and hold on 1 second, folks. Sorry. All right, folks. Sorry about that. We lost a network connection there for a second. We're going to ask another polling question here is, we'd like to know, how do you convey critical EHS findings and conclusions to upper management, okay? Do you do informal verbal communications as somebody's walking by, tell them what you're finding? Do you do formal written communications with no supporting data? Do you do written communication with data in a spreadsheet format? Or do you do graphical presentations with detailed analysis? So we'd like to know what your practices are now, so we're going to open up the polling question and just, kind of tell us on a day-to-day basis how you guys communicate with upper management. All right, we're just going to take a couple seconds here, make sure everybody gets a chance to tell us where you're at. All right, looks like we got everybody's response, so we're going to go ahead and share that information with you. And it looks like most of you are doing graphical presentation with detailed analysis, 44%. 44% written communication with data and spreadsheets, and 11% say written communication with no data. Okay. Let's take a look here once. And here we see a bunch of words on the screen. Well, folks, we're having some connection issues here again. Just hold on, please, for 1 second. We apologize. Never fails with practices. Once this morning, twice yesterday, never had a problem. And when it's time to go, we're having a little bit of technical difficulty here. All right, looks like we got the connection back. Again, we apologize. But here's a bunch of words on the page, right? You got a bunch of words. They don't look like they correlate to anything. So if I asked you, what is this? What would you say? Very difficult to say what something like this is, right? So, but if we take a look at the next screen, every word that you saw there is in this picture. Okay, so it's just kind of a reminder that it's better to be graphical where we can. A lot of times we say a lot of words, upper-level management. They hear our mouth move, but they just sometimes don't get what we say, right? So, my rule of thumb is that the higher you go up in an organization, giving presentations, the simpler it has to be and the more graphical that it has to be. All right? So let's start off then talking about statistical process control charts, right? In a nutshell, if you don't know what these are, it's basically a graph used to study how a process changes over time. You'll see on the graph that it has a central line. That central line is the average. And on the graph itself, it'll have an upper line, which we call the upper control limit, and it'll have a lower line, which is the lower control limit. The most important thing to know here is that statistical process control charts show how your process normally runs. You can't change the upper limit line and you can't change the lower limit line because this is how your data set normally runs, okay? Again, the lines are determined from historical data, and it provides the ability to draw conclusions about whether the process variation is consistent, in control, or is it unpredicted, which is out of control, affected by special cause variation. We're going to spend a lot of time today talking about special cause variation because it's so important to understand when your process is starting to go out of control so that you can fix it, you can identify it and fix it and get preventative before something happens, okay? Individuals in moving range control charts are used for variable data, and we use these charts in pairs, okay? The top chart monitors or shows the average, like we talked about, the centering of the distribution data from the process, while the bottom chart monitors the range of your data or your width of your distribution, okay? And if you think about if your data was shots on a target, in target practice, the average is where the shots are clustered, and the range is how tightly they're clustered on the sheet. All right? So, some tools. Okay, we just talked about the INMR chart, very good for plotting workers' comp data, very good for wastewater effluent data. If you're just plotting the number of injuries, not the injury rates, but the number of injuries, if you're just plotting the number of BBS observations, the individuals and moving range chart is the ideal chart to do that. For safety incident rates, you have to use what we call a U chart, okay? And the U chart is used when you have attribute data, and when we're talking about safety data, we have attribute data that we're counting the number of injuries, but we have changing and variable sample size. And the sample size that we collect when we calculate our injury rates is the number of hours worked each month. And as we all know, our number of hours changes month by month by month. So this is why the U chart is the chart of choice for plotting your safety data. Okay? We're going to talk about regression analysis. It's used to determine the relationship between two variables. For instance, the impact of the number of BBS observations on the reduction of injury rates. We're going to talk about a t-test. Is there a statistical improvement after a change was made? Did our injury rates or workers' comp costs reduce after implementation of an ergonomics program, PPE program? You know, name your program. You want to check to see if you made a positive change after you made those changes in your program. And then again, we're going to talk about capability analysis, my favorite. How capable are you to stay within your permit limits? Again, we'll talk about the city one to reduce your limits, and can you stay in compliance with the new limits? So let's take a look at our very first, this is an individual and moving range chart. Again, we talked about there's two charts. The top chart, very simply, is we're just the blue lines and the blue dots, or we're doing nothing besides plotting our data in a time series, right? So we're connecting the dots as our process runs through time. It looks like a heartbeat, if you will, going up and down, up and down. The green line is your average. So this is zinc that's coming out of our wastewater treatment plant, and the average over this time period of 3 years is about 0.15, usually milligrams per liter, right? Average over this time period. The bottom red line tells us normally the lowest point that this process will run. Never usually runs below the red line. The top red line is the upper control limit that says we should never run higher than this line based upon our data, okay? So if you take a look at it, statistics will tell us that between the two red lines, our data should all fit between these two red lines 99.97% of the time. You start to see these red dots here. These indicate that there's special cause variation going on here. What this means is that there's something happening in your process that isn't right, okay? That's running out, is starting to run abnormal, and there's a cause for that running abnormal. The issue behind this is that if you don't go out and understand your process to understand why these special causes happened, your process can start to run out of control on you. And if we take a look going back from the beginning when we started to capture this data, all the way to our first red dot, that process was in control. When we got the first red dot, it was saying, hey, there's a special cause variation going on here. We chose to do nothing about it, and as time went on, we saw that you can see now the process is starting to rapidly run out of control. And this is how most EHS people get in trouble at a site, is that they don't understand their data, they're not looking at their data, they're not reacting to the data, and as an outcome, typically these types of systems then will run out of control over a permit limit, and you'll get a violation, a notice of violation that you exceeded a permit limit. I can't stress enough how important it is to look at your data, analyze your data, and react to your data so you can get very predictive as we go. Just real quickly, the bottom chart here is the moving range. The only thing this chart does is it's pretty simple. It takes two consecutive points up above and it subtracts one from the other and it plots the difference between the two. So if you had 1 point at 0.15 and the next point at 1.5, when you subtract the two numbers, you'll get to a 0. So this tells us that the difference between any 2 points is averaging 0.07. It should never be more than 0.22, and it should never be less than 0, obviously speaking there, right? And as you can see here, we had an abnormal point back about, looks like, I don't know, summer of '04. We had an abnormal point there. That was our first indication that the distance between those 2 points on the chart, the statistics tells us is that's abnormal. And that's really the first hint that we should have been looking at causes to what happened there. So again, I can't stress enough how important plotting your data is, understanding control limits, understanding when your process is starting to go out of control. Okay? Here's a U chart. Very similar to what we see here. The individual dots is I'm plotting the monthly recordable rate, if you will, on a time basis. And what I did then is I blocked this off in years to take a look at my 12 data points each year. And as you can see here, this is a great way to show management what happens after we implemented a personal protective equipment program. The next year then we implemented a temporary employee program. We dropped our rates again. We implemented an ergonomics program. We see our rates dropped, and then we implemented a BBS program, and we didn't get much bang out of the buck for our BBS program. But again, look on how important it is or how vital this is when you report out to management so they can see that, you know, our efforts that we're doing are paying off. Powerful chart. Okay? Here's one where you know, we're showing the difference in a process shift. Okay, we made a change here. This is we're looking at our workers' comp cost. So we said, hey, let's plot the data before we did our ergonomics program, and we see our workers' comp costs there at about $1.6 million on average. Okay, kind of hovering around there. We did an ergonomics program, and we took a look at our rolling, same data, rolling 12 months, and as you can see, it dropped down to $1.2 million. So great graph to show management that, hey, the money that we're spending on ergonomics is starting to pay off. Look at our workers' comp numbers starting to come down. Look how much the variation around the mean is starting to tighten up, so we can predict better and business plan better on how much monies we need to set aside for workers' comp. Again, powerful graphs when you're showing leadership. Let's take a look for those black belts out there. You know, I'm sure I'm going to get a note that, Dean, you're never supposed to put your permit limit on your SPC chart. Certainly understand that. This is for training purposes only. What I wanted to show you here is this is some data around the wastewater treatment plant. Again, the green line is the average. The individual dots is our data. The dashed line here, apologize, it's a little bit different. Dashed line here is the upper control limit. Sometimes it's called the upper natural process limit. This is how your process normally runs, okay? The red line we put on here now is your permit limit for zinc, okay? So take a look at this chart and tell me what you see in this chart, okay? We're going to take a minute here to do a polling question, okay? And the question is, how would you describe this process? Is it stable and in control? Is the mean below the permit limit? There's a small degree of variation, none of the above, or all of the above. So take a minute there, take a look. We're going to open up the polling questions and tell us what you see in that chart. All right, a couple more seconds here. Let everybody take a look. All right, we're going to go ahead and close out the polling question and show the results here. 11% of you said that it is stable and in control. That is correct statement. 17% said the mean is below the permit limit. That is also correct. 17% said there's a small degree of variation. That is also correct. I'm happy to see that nobody picked none of the above. But the correct answer is all the above. All those things are true that we said about that process. So very good. All right, let's take a look at the next chart. And kind of the same thing here. This is taking a look at chromium. We see that the green line, we see the lines, and now for the first time we see a point that's above the upper control limit. And again, that's a special cause variation. Something caused that to happen. That's just not normal. Something caused it to happen, and even though you didn't exceed your permit limit here, the fear is if you don't go out and do a root cause investigation on why that happened and correct it right away, okay, you can potentially break your permit limit. Now, from a wastewater treatment plant, when you do your root cause analysis, there's a lot of things that may have happened, right? Maybe your chemical ads ran out. Maybe you have a brand new operator and he wasn't sure on how to run the system. Maybe the sand filter failed. Maybe your flocculants ran out and you didn't get enough flocculants in that batch. Until you figure out what happened there, find the root cause and put in the corrective actions, that can continue to happen to cause you a lot of problems and a lot of heartaches in this world. And trust me, folks, I've been there. Okay? Let's take a look at this chart. Okay? And again, we're going to ask a polling question here, so take a look at it. And let's ask the question, what does this chart tell you? Does it tell you nothing? There's no problem here? Does it say that we're okay, these data points are not normal, this process normally runs above the permit limit, or there's no special cause variation here? So let's open up the polling question and let's take it, see what you see with this chart. All right, a couple more seconds here. Yeah, and just a reminder, if you got questions as we go, you can go ahead and submit those questions as we go. We're going to collect them all up, and at the end, we'll review your questions, so you don't have to wait till the end. let's go ahead. We're going to close this poll out. Let's take a look at the results. And good says we're okay. These points are not normal. That's not exactly true. This process normally runs above the permit limit. That is correct. The correct answer is that this process normally runs above the permit limit. And let's go back real quick and just take a look at that chart again to review it so make sure people understand. Let's go back one more. There you go. So again, take a look here. Just want to make sure everybody understands this. The green line is the average. The dotted line is the upper control limit where the process normally runs. Okay, and the red line is the permit limit. So as you can see here, we have a high degree of variation around the mean. And unfortunately, what it's telling us here is that sometimes our process runs out of control, or runs not only out of control, but it runs above our permit limit. Okay, so this is a very bad process and something that needs to be addressed right away so that you don't get in trouble in the future. All right. Let's take a look at this one. This one is interesting, okay? This is, say for instance, an air monitor that's monitoring chromium at a fence line. You can see here back in early of 2012, nice tight process, a stable mean, right? Very little variation around the mean. Things were going really, really good, right? And then all of a sudden about April 1st, things started to go out of whack. Our mean rose, the variation around the mean, we see, you know, loads of special cause variation here, and then all of a sudden you get a letter from the state saying you're out of compliance and you owe me $250,000, okay? Imagine the power if your EHS person at this plant was plotting this every day and he was looking at the data. At the end of March, things were fine, and he put in the data point for April 1st, and he saw that something happened. If he would have got out, he or she would have got out and took a look at what happened, did a root cause investigation, could have saved an exceedance there, could have saved some pollution to the environment, to the community, could have saved the business a lot of money. Didn't look at the data. 6 months later, you know, get a letter from the state, you're out of compliance. We go back and do a root cause analysis, you know, a week's worth of root cause analysis, talk to the maintenance guys, pull the maintenance records, and the maintenance guy said, we changed that kettle on that stack, or on the stack that goes to the environment on April 1st, and we forgot to put something back in. Okay? Very powerful that we did the root cause analysis 6 months later and found it. But think how powerful it would have been if we'd have found it at the time that it happened, okay? So again, I just can't stress enough the importance of control charting some of your environmental data, okay? Let's take a look at a student t-test. I'm not going to spend the time, you know, talking through these points. You'll certainly have access to this presentation when you're done. You know, if you want to learn about t-test, about the background of them and the mathematical statistical part of it, we put this slide together for you. But what I want to show you is what a t-test looks like graphically, okay? So here we're taking a look at injury rates before and after implementation of an ergonomics program. Now the statisticians will tell us that, you know, in order to get the most accuracy, you need 25 data points on both sides before and after to get your most accuracy. Let's face it, folks, we're not doing brain surgery here, and we're not building the next rocket that's going to the moon, okay? So if you have 10, 12, 15 data points, I say plot them, all right? So what we do is we take a look at what were our injury rates before we did ergonomics program, and what's our injury rates afterwards, okay? This is a powerful graph. We call this sometimes a box and whiskers plot. The whisker, if you will, the top whisker on the right is the fourth quartile. How many of your data points fall in that fourth quartile? The center box is your second and third quartile. Your bullseye in the middle is your average. And then a lot of times you'll have a whisker at the bottom that shows your first quartile data. The important thing to me here is two things. One is taking a look at that line before and after, your injury rates. And when you do a t-test on the statistical package, right, you have to do this usually in a software, it spits out what we call this p-value, all right? Bottom line, when the p-value is less than 0.05, then you have a significant change. Here it spit out the p-value is less than 0.009, so we can statistically say that our ergonomics program is paying off, and we statistically changed our injury rate before and after we implemented an ergonomics program. Just, again, a powerful tool to be able to go to your CFO if he or she's complaining we're spending too much money. You know, just a great tool to show people where we're at. Okay? Regression analysis. Love regression analysis. It's a very simple tool to use. You can do it on Excel. You're testing to see that what happened when you changed X, and X can be anything from flow, number of BBS observations, chemical adds, etc., that changed Y. Okay? Y can be anything like your concentration, number of injuries, parts per million, etc. I got burned on this once. I was at a site, and the site said, hey, we had a copper exceedance in our plant, and the reason for it is because we're not manufacturing much in our plant anymore, and our flow is way down. So, and they said, you know, because we have no flow, it's down. So I kind of took that as, okay, these people know what they're talking about. Sat around fat, dumb, and happy. 3 months later, we had another exceedance. At that point in time, I blew my lid, and I said, let me see the data, did a regression analysis, and guess what? There was no correlation at all between flow and data. What happened is that the underground sewer pipes haven't been cleaned out in decades. There was copper buildup in it. Somebody was using a cleaner that was slightly acidic, dissolved some of that copper, sent it down the pipe, right? So let's take a look. Let's give an example. You implemented a behavioral-based program over a year ago. Your VP of Operations says she hasn't seen any changes in the injury rates since starting the program. The VP of Operations said that it takes too much time to perform the BBS observations and asks, can we cut the number of BBS observations by 50%? Okay? So how do you respond to her? Somebody comes to you with this kind of, you know, request. How do you respond? Right? Well, you respond by taking a look at the data. Okay, here's the data in the table format, and it's difficult to tell here. If we remember, you know, a picture paints 1,000 words. So let's take a look at this thing from a picture standpoint. Very easy to do in Excel. Left-hand column, we do what we call a scatter plot. Okay, tell Excel in the graph to do a scatter plot. The graph is generated, and then you do a right-click and you say add a trend line, and then you click and say add the R-square equation. So when the R-square values are less than 0.8, there's no statistical correlation between X and Y. And when your R-square value is greater than 0.8, then there's a statistical significance. So as you can see here, this data is showing that as we increase, I'll tell you what, let's take a poll. You tell me what you see here, okay? So now that you've seen the data, what do you tell the VP of Operations? Do you tell them do you say, okay, we agree to 50% reduction. You tell her that we continue as we are. You make a case that the more observations we do, the less injuries we have. Or you do a graphical presentation with a detailed analysis. Okay? Oops. Sorry, you agree to 50% reduction. You recommend that we continue as we are, or you recommend doing more observations. All right, let's give a chance to everybody to take a look. All right, a couple more seconds here. All right, let's go ahead and close out this this poll. We'll take a look at the data. Agree to the 50% reduction. I don't think that's a wise thing to do. The data kind of showed us that the more observations we do, the more we control our injuries. Recommending that we continue as we are. Probably not a bad thing. You're doing pretty good. Or recommend doing more observations. And I think the data If we go back, let's take a look at the data again. I think the data certainly supports that the more BBS observations that we're doing here, certainly, as we get up in the, the 400, 500, 600 range, we see our injury rates continuing to decline. So I think the data would certainly support doing more. Certainly, it looks like there's a sweet spot there. Greater than 400 looks like we're getting a big bang for our buck. Again, this is how you would answer those types of questions if somebody comes to you and asks. Okay, let's talk about capability analysis here. Okay, anytime that you have a permit limit and you're gathering data, you can do a capability analysis. Doesn't matter if it's your stormwater data, doesn't matter if it's your metals data, your pH, your flow. If you're taking measurements, differential pressure gauge monitoring, if you're taking measurements, and if you have a permit limit, you can calculate capability. Okay? So we take a look at this process. This process is fairly stable, fairly in control, got some special cause variations going on there, but not too bad of a process. But how capable are you? Okay? So let's say, for instance, and I need to take time to explain this to you for a minute, but this is what happens when you put the data into a statistical process software. Okay? What you're seeing there is if we took all those points on that graph and we just put them in buckets, and these buckets here is a frequency chart, right? The more that you have in those buckets, the higher your graph is going to be. So there's a lot more in the 220 or 210 to 220, 230 range there than there is in the 160 bucket, right? So what the computer then does, it draws a bell-shaped curve saying, 99% of your data should fall underneath this bell-shaped curve, right? The dotted line on the right is your upper spec limit. It shows you that your limit is 325 and that your data normally falls underneath this bell-shaped curve. The distance between your spec limit, your upper spec limit or your permit limit, and that little tail at the end, that's how capable you are. And I tell a story, if you think about, our weight, if my wife said, hey, how capable are you to stay within your ideal weight? I'm not so capable. If she says, hey, do you think that you can stay underneath 1,000 pounds? I'm pretty capable of staying underneath 1,000 pounds, right? Same way with our permit limits here. How capable are we to stay in compliance here? So what I like to do here now is to calculate a sigma value. When we talk about Six Sigma, for those of you who haven't been trained, means about, I think it's 3.4 defects out of 1 million opportunities, right? So to calculate a sigma level, we either take the CPK or the PPK that's generated up here. We see it's 1.48, and we just multiply it by 3. So here you see that this operation runs at about a 4.4 sigma. And now you're sitting back and you're saying, okay, Dean, that's good and great. What does 4.4 sigma mean? I'm glad you asked the question. Because if we take a look now, and if we're doing 24-hour composite samples on a daily basis, just like they did to me in my sewer hole, if I'm running at 4.5 sigma, it's going to be about 1,000 days before I'm out of compliance, right? 1,000 days is a little bit less than 3 years. At 4.5 sigma, if somebody's sitting out in my sewer hole every day, I can sleep pretty good at night knowing it's going to be over 3 years before they find me going out of compliance. Not too bad, okay? So now let's take a look. The city wants to lower your limit from 325 down to 275. Okay, so what's your capability at that point? It's the same data. It's the same data underneath the bell-shaped curve, but now look what the city did to you. Even though you've never had a data point outside of the 275, all your data runs below 240, but your process will normally at some point in time run over your spec limit, okay? Again, let's calculate a sigma value. We calculated at 2.8, and if we go back to our chart at 2.8, we're going to be out of compliance about once every 150 days. So about twice a year, if somebody's camping out in our sewer, we're going to get permit exceedances twice a year at that kind of level. Okay? So very, very important when the city says, hey, I want to reduce your limits, is that you understand what that means to your process. Let me show you some work that I did for a company. I took a look at every effluent around the world that they had a permit limit for, and I calculated the sigma level. And when I calculated the sigma level, I showed management, on average, if somebody comes and camps out in their sewer hole, these locations are going to be out of compliance once every 3 days. You should have seen the checkbook open up and the instructions I got to go to those sites and do optimization projects on these sites that had very little capability of being in compliance. Again, a very powerful graph. I can tell people that, hey, we don't have good capability, but seeing it in this way, seeing it real, really, really changes things. We talked about 4.5 sigma being out of compliance every 3 years, right? 6 sigma, I was working with one company that for every new pollution prevention device that they put in, they wanted it to have 10 sigma capability. If you'd imagine 10 sigma capability, that's running for like over 1,000 years, right? Continuous monitoring, never going out of compliance. Talk about being able to sleep at night as an EHS person responsible for compliance. Knowing this kind of information is vital, vital, vital in the roles that we do. And I'm just shocked on, this isn't really taught in too many places, and this is really, really a shame. Okay, just a little bit of capability analysis, summary. If you have a permit limit, for stormwater, all your wastewater effluents, fence line air monitors, industrial hygiene exposure monitoring, differential pressure gauge readings. If you're capturing data and if you have a limit, you can calculate a capability, do a capability analysis. All right, so in conclusion here, in order to bring true business value, you must be predictive to become preventative. When you can predict that you're going to be out of compliance, you can go in there and fix it first to be preventative. So these simple Six Sigma tools can assist you. Don't take statements and tribal knowledge as facts, okay? Show me the data. I've been there. I got in trouble. Shame on me. Never again if somebody says we changed X and Y changed. Without them showing me the data, don't believe it, okay? Now remember, I showed you some data here that was kind of fictitious. You got to remember, so that I showed you, don't go leaving here thinking that, hey, if I just go in there and do these 1 or 2 things, I'm going to be set. There's no silver bullets to increase EHS performance that builds business value, but there's many pieces of silver shots. There's a lot of things that we do that we have to continue to do. We can't just do one thing. And if there's one thing I hope you remember is that in God we trust, and all others better bring data when it comes to compliance, right? Okay, we're going to take one last poll here, and then I'm going to have some recommendations for you. And I just want to note, does your company have a formal Six Sigma or Lean Six Sigma program? Either yes, they do, but you've not participated, yes, and you have participated, or no, my company does not offer a Six Sigma program. So let's go ahead and open up the polls here. One last poll. Take a minute and let me know where you're at in this world. We're still waiting for a few more people here to vote. Okay, one last chance. All right, we're going to go ahead and close this down, and let's take a look at the results. So 18% of you said yes, your company has this Lean Six Sigma program or Six Sigma program. You've not participated. Folks, I couldn't stress more getting there. Some of you said, yes, I have participated. Congratulations, good for you. I hope this presentation really opened your eyes. And the first thing that you should do when this presentation is over is go hug on a black belt and ask them for some help, okay? Unfortunately, 41% of you said, no, my company does not offer a Six Sigma program. I've got some recommendations for you. So let's take a look at the very last slide here for some recommendations. Okay, first of all, if your company offers a Six Sigma program, sign up to be a green belt. Tell them you've sat through this. It's vitally important. We don't know what we don't know. Get on the list. If you have to kick somebody off the list, get on that list so you can get through the program, all right? If your company doesn't have a Six Sigma program, you probably have a quality group. Go partner with your quality group. Again, this presentation is going to be available to you. Feel free to print it off. Tell them that you want their assistance in doing some of these things. Get the help that you need out there to assist in evaluating your data. You know, really, as an EHS professional, add value to your company. Being predictive is the best way to be preventative. When we're preventative, we help control injuries, we help control out of compliances, we help control cost. Okay, so get out there, be predictive. Okay, and lastly, if you're not using an EHS management information system to capture your vital data, you may be missing out on opportunities to be predictive and be preventable. And a little shameless plug here for Process Map. I'm working with these folks to be able to automatically generate some of these things for you in their software, their future versions of their software. So again, you know, the Process Map people can really help you with your data. Okay? So with that said, we're going to open it up for some questions and answers. Feel free to ask some questions here as we go. All right. Folks, if you have any questions that I can answer for you, please don't be shy. We got one question coming in here. It says, first question we got is, it says, these tools are helpful when you have a lot of data. That's correct. Okay. Please advise on how do I go about getting the right sets of data. Well, you know, we gave you a lot of examples today on either, you know, workers' comp costs, your injury data, your environmental data. Again, you know, the truest, the mathematicians and the statisticians out there will tell you that you really need 25 data points. You know, I say, you know, if you got 10, 12 pieces of data, take a look at it, see what it says, you know. Getting the right sets of data, you know, you got to really think about, okay, I made a change here. What is it before and after? So what are you measuring? What's your KPIs? Are you measuring workers' comp before and after you put in your ergonomics program? Measure your workers' comp dollars. If you're measuring, you know, hey, we used a new flocculant, or we're using more of the flocculant, you know, has our copper changed on the back end? You know, you could do a regression analysis on the amount of flocculant used versus the concentration of copper at the back end. So it all depends what you're measuring or what your KPIs are in your programs that you're putting in and the changes that you're putting in to see if you've affected change. Okay? Second question, are these tools limited to just environmental data or can they be extended to safety as well? I thought we did a pretty good job of showing you some stuff on injury rates, doing T-tests before and after, using workers' comp data. Again, anything that you're measuring in a time sequence, anything that you're measuring before and after change, you can use the data for both environmental, for both safety, and for workers' comp. Okay? I think we got a third question here. Which software do you use to generate charts and graphs? All right, shameless plug here for, I've grown up doing Six Sigma since the late 90s. And when I was taught on how to do Six Sigma, the company that trained me was using a statistical package called Minitab. I've used Minitab a lot. Some of the charts that you did see, though, actually the company I worked for wouldn't allow me to buy Minitab. So I went out and I found the equations on how to calculate or how to actually build an I and MR chart, and I built my own Excel spreadsheet and plotted the material itself. So many times the only one I've ever used. I've not used any others, so I can't speak to any others. All right. Got another question coming in here. Which types of graphs and charts are useful for different sets of data? Again, we talked about for most of the environmental data, when we're just counting things over a period of time, the individual and moving range charts is the best one to use. It shows us the best things. For the safety data, though, because our hours change every month, we have to use the U chart in plotting the safety data. Okay, so those are the two best ones to use for EHS data. Next question, is there any literature or websites that we can learn how Six Sigma is used in EHS rather than taking a full-blown Six Sigma class? There's none that I know of, okay? But I've not researched it, okay? But it's a novel idea, and maybe you just gave me a new business venture to get into, because I got a lot of passion for it and would certainly love to teach this type of stuff. But again, this is something that you can't learn in an hour webinar. Greenbelt training is usually 4 to 8 weeks worth of training. They teach you a lot of different things. And again, there's many more tools than what I showed you, but these 4 tools to me made the best sense of applicability to the EHS data that we use on a day-in, day-out basis. Next question. My company has a Lean Six Sigma group, but is limited when using it with EHS data. Can you recommend any books or other resources that can help specifically with EHS data for Six Sigma? Again, I've really not researched it. I did it the old school way by going through Six Sigma and then applying it myself. I don't know what's available out there if you Google it. There are obviously some good Six Sigma websites, but most of them are for design of experiments, using it in quality, manufacturing parts to certain specifications. How capable are you to manufacture parts? But I recommend as you go through these types of training, as you're learning these concepts and learning these tools, always be thinking in your head about the things that you're measuring in EH&S, whether it be injury rates, workers' comp, BBS observations, number of risk assessments you're doing. Be thinking about how you can apply the things that you measure in the Six Sigma world. All right, any other questions? All right, I think that's all the questions that we have. I certainly want to thank you for your attendance today, and I'll give you back to O'Neill.
All right, well, everyone, we thank you very much for joining us for this Process Map Education Series webinar. As I mentioned previously, we are going to be sending out a post-webinar survey. So please, take a moment to complete that for us, provide us with some feedback on how we did on this webinar. And then finally, just as a thank you, we are going to provide you with Dean Rossi's contact information. So if you have questions specifically for Dean, his email is up on the screen. Please feel free to reach out to him directly. If you have any questions about Process Map or our solutions, you can reach out to us as well. And we'll leave this up for you for a couple of minutes so you can take the information down. So thank you once more, and we'll keep you posted on our other upcoming webinars. Thanks again for joining.